Well, thank you for having me here tonight. I want to talk a little bit about adaptive automation and how I see it playing out in healthcare. Um, First, I'd like to introduce you to Dr. Spencer Silver. He's not a medical doctor, actually. He was a chemist who worked at 3M. And in 1968, he set out to build a glue that was stronger than super glue. He wanted a glue that he could actually use in airplane construction. He failed utterly. What he came up with just didn't work. It kind of stuck, but it didn't stay stuck, and he gave up on the project. And in about 1974, another person, Arthur Fry, was trying to get a bookmark to stay in his hymnal as he was singing at church, and he remembered this failed project from 3M, and that's how the Post-it note was born. What many of you may or may not know on this call is that healthcare runs on Post-it notes. There's all kinds of places in healthcare where people are writing down little things and sticking them various places. Why is that? Well, if you look at it, there was an estimated about 56 billion transactions with credit cards in 2024. In your body, there's around 30 trillion cells. And if that wasn't enough, there are also 30 trillion bacteria and microorganisms living in there, right? So the order of magnitude of complexity in one human is bigger than the number of credit card transactions. And if you look at it, a credit card transaction is pretty much the same, right? They have an amount and they have a place that they're going and a timestamp. There may be some variations in little fields. If you think about a person, you might have one lab test today and another lab test at the end of the year. And then your neighbor might have 20 lab tests a month, right? The kinds of data and the variability in the data are just huge. And finally, healthcare is not binary. A credit card transaction, either the credit card transaction goes through or it doesn't go through, right? There's obviously some wiggle room, and if we look at the financial crash in 2008, obviously people had created some really interesting wiggle rooms, but in general, finances is pretty binary. Healthcare isn't, right? For one patient who's dying of cancer, they may want to stay in the hospital and get all the care they possibly can get. Another patient may decide to go home and live out their life on palliative care. Neither of them are necessarily right or wrong, right? It's just the situation and the patient involved. I mean, even if we look at something simple like getting a patient out of the hospital, right? So let's say we have a patient who's been tagged to go to rehab. We're going to need to find a rehab bed for them. We're going to need to get meds together for them. We're going to need to have maybe the cardiologist clear them, some labs. We're going to have to write some discharge instructions for them. That's going to lead to some other activities, right? Which is going to lead to even more activities, right? And this ends up looking like a pretty classic workflow from anybody's point of view, right? But the patient in the bed next to them might have a completely different workflow. And what's even more is that as time goes by, that first patient's workflow might change. The cardiologist might say, hey, I want them to have a heart monitor before they go to the rehab, right? So then you got to order that heart monitor and make sure it gets delivered before they go. Also, maybe their blood count comes back high in a lab test. And now all of a sudden you got to scrap everything, right? The workflow is not going to happen because you're not going to send them home because you have to figure out what's going on with that lab test. As I say, traditional automation, what we do is we get a room full of experts together and we sit down and we figure out what the process might be and how we might change it, and we roll out that change, right? That becomes problematic because it takes a long time, right? It also doesn't handle all those exceptions very well, right? Things change, it doesn't handle them, and it doesn't learn, right? So it doesn't adapt over time. So how do we solve that? Well, we solve it with a network of agents, right? We can have a network of agents all talking to each other, and these agents can come up with what that plan should look like. And even better, they can monitor over time and show how that plan should change, right? Now, for today's world, we definitely want a human in the loop. So we're presenting that plan to a human before we execute on it. In the future, right, we're going to train these agents and they're going to actually be able to solve problems. That network of agents is going to be able to solve problems interacting with people and sensors and tools in the environment. But for right now, we really want a human in the loop. We want the agents to come up with the process and then help with some pieces of the process. So really quickly, why is this possible now? Why can we do adaptive automation now? For the longest time, we've been looking at, computer systems need to be deterministic. We want them to put the same input out in, we're going to get the same input out, right? I think everybody on this call actually probably is more steeped in this than I am, but I really become convinced that non-deterministic systems are actually more powerful than deterministic systems. That the fact that there is randomness, weighted randomness is weighted towards positivity, but the fact that there is randomness in the system actually makes it more powerful. And today we have large language models that make that a reality, right? They have some non-determinism, but they're weighted in the direction that we want them to go. And if we put them at the heart of an agent, they really have a lot of power. So what do we need? What do we need for adaptive automation? First, it's really important what platform that this stuff gets built on, right? I'm not sure that we think about this enough, right? We really need it to be built on a reactive platform. And what do I mean by reactive platform? Reactive is the Reactive Manifesto came out a number of years ago. It was talking about how we build modern software. And it came up with the concept of it really needs to be responsive, which means that the platform itself needs to behave similarly over time. In order to do that, it needs to be elastic. So it needs to be able to scale, and it needs to be resilient. It needs to be able to be self-healing. In order to accomplish all of that, it really needs to be on a message or event-driven backbone, right? So that is super important that we build these systems on an asynchronous platform that's able to handle the communication between agents with guaranteed message delivery and the right security and all of those pieces that make up a reactive platform. They're going to need to be able to learn. They're going to need to be able to adjust over time. And particularly in healthcare, they're going to need to be able to build trust, right? Heard a great saying recently, which is that healthcare moves at the speed of trust. A lot of people say healthcare is slow to adopt new technology. I think it's probably not slow to adopt new technology. It's slow to trust new technology. But if you can get over the trust barrier, you can introduce new technology in healthcare actually fairly rapidly. So let's look at 3 perspectives on how this could play out. And we're going to actually get into some agent systems that I built on Vantiq. So let's start out with Rick Van Moort. He's a primary care physician. He sees patients all the time. We're going to look at a little interface that's going to help him out. So he's just completed a visit with a patient named Alton. Some ambient technology captured that visit, and that's great. We got a transcript of the visit, but it's what can you do with that transcript? So we're going to upload that transcript to the system here, and the agents are going to start working on his behalf. First, they're going to summarize the visit, and then they're going to look at what the next best action should be, and they're going to suggest that to the doctor. And in this case, it's upping the dose of amlodipine, which is a drug that particular patient is on. And what it's going to do is the medication agent is going to actually find out information from the patient and from the general world and write a new script for amlodipine. I'm representing it here in the FHIR, F-H-I-R format, just because that's a standard interoperable language for healthcare. But we could imagine that it would be presented to the actual user in a much better user interface. But what you've seen there is actually a set of agents, all talking to each other and all talking to tools. So Alton, who's the patient, so that's the patient agent, has access to Alton's healthcare data in a FHIR database. The medication agent that was responsible for writing the medication request resource has access to RxNav, which is RxNorm is the coding system for medications in the United States. And so it has access to that API to look those up. And there's actually a checker agent that also has access to that API to make sure that it did a good job. All of those agents, I actually follow a pattern where I use a planner, and then it has executions, and then a response. So you can actually even think of each of those as their own agents. So I call it a macro agent and micro agents. And each micro agent is pretty much what you would expect it to be: a set of tools and external memory around a prompt that feeds into an LLM. So that was great, yeah, but what else can we do? I sent this to my boss, and my boss showed it to a potential customer, and the potential customer said, "That's great. We don't care about writing medications. We're really interested in detecting what are called adverse events. We want to make sure that people in studies, if something happens, we detect that it happened. Can you do something about that?" So we're going to look at Masakai here, who has Dr. Rick as her primary care, but she's also got cancer, unfortunately. And recently she called Dr. Rick up, and she told him that something doesn't feel right. Her oncologist has her on an experimental drug. He told her that there'd be some side effects, and just told her to kind of tough it out, because he didn't want to ruin the study that he was in. But she's experiencing paralysis in some limbs, and she wants to know if that's normal. Now, this came into Dr. Rick as a voicemail, right? A voicemail could sit in his mailbox for a day or more until, say, a nurse picks it up and maybe listens to it. And then then they realize maybe that something's wrong, and it goes to him, right? We need to be able to deal with that a lot faster. This is a serious problem paralysis, right? So what if we upload that to the same agent system, right? But if you look very closely, you'll notice I've added a new agent, which is the quality control agent. And the quality control agent is going to see the fact that there is an incident that's happened, and it's going to actually be able to realize that because the patient's in an experimental drug, they really need to let the government know, or whoever's running that study, right? So great. But I mentioned to you that we also need to have these be able to learn and adapt over time. So let's talk a little bit about that. We have Sarah Smith here, she's a mother of two, and she's just become responsible for her parents-in-law's healthcare. So she's really acting as the air traffic controller for her entire family's healthcare. That's a big responsibility. There's a lot of work involved there. And Sarah really needs a set of agents that are going to help her. They're going to learn about her family and actually be able to help her. Now, there are a number of ways we can build these systems that can learn. We're actually working on some really interesting stuff here at Vantiq, which I can't get into here, but I'm going to show you an example of the kinds of things we're thinking about. So one way we could do is we could fine-tune LLM. So we could actually have a fine-tune LLM for each thing that we want to learn, right? Very expensive, not necessarily efficient, but it is a possibility, right? The other thing we can do is modify prompts. And finally, we could actually add whole new agents to the system, right? I mean, an agent in the end just becomes a system prompt and an LLM combined with some tools. I would argue that LLMs are pretty good at writing things. Prompts are just text. So why can't you have an LLM write a new prompt and create a new agent? I'm not going to show you an example of that yet, but what I am going to show you is this prompt rewriting as a possibility. So we're going to go back and we're going to look again at this encounter that happened. We sent off that medication request for upping the dose of amlodipine, right? But if we go back and we look at the transcript and the summary of that transcript, it actually identified more steps that should be taken. And one of the steps was to order some blood work with an A1C test, right? So before we do anything with that, I want to just come over here and I want to look at the system prompt for the observation agent. Now, the observation agent is the agent that's going to get any new lab results that come in. And I could explain to you why the nomenclature of observation agent, but you really don't want to hear that explanation. But the point is that we have this agent, it's going to get all the lab tests, and it's right now instructed not to notify the doctor unless it has a real reason to believe that it should not notify the doctor. So that's that statement there. If you don't have enough information to decide they should be notified, do not notify them. All right, so now what I'm going to do, is Dr. Rick's going to type in that yes, he does want to order that blood work, sorry. Further, he'd like to know if the A1C comes back as higher than 8.7, right? So he's interested in this particular lab test if it's a particular value. And so what we do is we actually rewrite the prompt on the fly to have that information in the system prompt now, okay? So now when we go and we upload some lab work, in this case, we happen to have a PDF which has an A1C for this patient. We're going to upload that PDF. It's going to go through a tool that's going to extract all the labs from that. Takes a few minutes, to go through as it's taking apart the PDF. It's going to find something like, I think there are 13 labs there, but only for one of them is it actually going to say, okay, out of these 13 labs, I'm going to notify the doctor about the one A1C because that A1C is in fact greater than 8.7. It's actually 9.4, right? So great. So this is some examples of agent networks that I built on the Vantiq platform. We're continuing to advance that platform. What does this ultimately lead to, right? What is it the ultimate goal here? Well, agents can do a number of things. One of the things they can do is they can really help the clinician or the doctor deal with the wealth of information that's available to them. CPGs, which are clinical practice guidelines, are instructions that institutions have come up with to say, here is the standard of care that we have for this particular condition, and here's the kinds of things you should do for it. There's also huge amounts of clinical research out there. There's information from the hospital about what procedures they can actually do. And then patient data that comes from the electronic health record, right? All of that is just information overload to the clinician. But agents can help them to summarize that down. And as we just saw, create various different care plans that can get executed. And then agents can also help do some of the menial work, right? They can do some of the things like outreach to a patient, right? Outreach to find that rehab bed that they need, those kinds of things. And what really excites me is that because they can do those kinds of things, we're finally going to be able in healthcare to break down what I call the encounter barrier. Most healthcare happens when you go to visit your doctor, right? So you go into the doctor's office or you go into the hospital and you have a procedure done or you have an exam done, you get some lab work done, right? But most of what affects your health actually happens between those visits, right? That's when you're making the decisions to eat that extra piece of cake or to not get up on your bicycle and ride today, right? That's when you're making the decisions that are going to affect your future, right? If we have agents involved, they can actually reach out. It's not cost effective for the doctor or even the nurse to call you every day to be part of your plan for how you're going to do every day, but agents can. And they can figure out how to do it and adapt in ways where they're not going to be annoying. They're not just calling you, but they're actually interacting with you and providing you with the incentives and the programs that you need to actually be successful in driving your own health forward in the positive direction. So that's why I'm really excited about agents in healthcare and what I see as kind of the future. As I said, all of the stuff that you saw today, all those demos were built on the Vantiq platform, and you should come check out Vantiq. And this other QR code is my contact information. And I'm happy to take questions and also have you reach out whenever.